Stefan Jülich. I'm from Intel, based in Munich, and I'm responsible for the technical computing area, which is HPC and workstation.
Hi, I'm Alan Priestley. I work for Intel also, and I'm responsible for our big data analytics marketing activity in EMEA.
We're actually here today at the ISC Big Data, and the reason why we are sitting together is actually this overlap between high-performance computing and big data analytics. Right? We were just doing a presentation together, and we give you a little bit of an insight of what we've talked about and the motivation of that. So if you look at HPC, obviously you have high performance. That's in the name of it. Right. Whereas if you look into big data, it's data analytics, right? And where do these things come together? That's the question. There's actually two areas. One is there's an overlap in the underlying technology, right? If you take Hadoop, which is one of the key tools for data analytics, and if you look into what is used in HPC, well, it's clusters of servers, right? And they look pretty the same, right? And Intel is obviously about to and is providing technology to and products to those servers, right? So there's a natural interest. But on the other hand, there's also an overlap more and more in the applications. I provided one example today out of the genomics area, where actually there's lots of data involved. So you say this is big data and you do analytics on the genomic data, so this is data analytics. On the other hand, there's also simulation being done, right, on bioscience data. So this area is actually providing a good example for the overlap of high performance computing and data analytics into what we call high performance data analytics.
Yeah, and as you say, while the HPC community has been processing lots of data and running analysis against that for an extended period of time, what we're now starting to see is that many IT organizations and enterprises are faced with the challenge of an influx of new data types. You know, in the past, they've just stored traditional data in relational databases and knew what they had, they stored it, they processed it, and they did business intelligence. But now what you see is there's lots of new data types coming in. We've spoken today here about IoT, Internet of Things, as a new data source. There's all the social media data sources as well, which are presenting IT organizations with a challenge. And they've got two challenges there. One is really how they store that data, what they do with it. But the other, the bigger challenge, is actually how they monetize that data, how they drive financial value or financial benefit to their businesses from that data. And so this is where the crossover comes in. You know, HPC is used to processing the data, or the HPC community are used to processing the data. Many IT organizations now are faced with huge amounts of data and have got to translate that into something that's of value to their business.
Okay, you also mentioned the importance of open source. So that basically it's, a lot of software is open source, it's needed, and you outsourced some open source to Cloudera.
Okay. Yeah, much of the software that's used for data analytics today and big data in the big data environment is open source software. A lot of it has come out of the folks in the US, like Facebook, Google, etc., who initially some of the first companies to face this challenge, and they developed their own solutions and they kind of gave that out into the open source community. So what we see now is that many enterprises are starting to pick up this open source software, Hadoop, things like that, some of the solutions there, and use them internally. You know, it's a quick and easy way to do it. It's minimal cost for them to get this and then start experimenting. You're also seeing a number of companies out there taking the pure open source software from Apache and converting that into distributions that they actually then make available to customers. And this is much the same as we've seen with the Linux community. You had a Linux distros and a number of companies providing support for them. You see the same with the Hadoop framework and a number of companies providing support for distributions, i.e. ease of installation, servicing, etc. Intel is very supportive of the open source community. We have a lot of contributors into the community. We provide a lot of source code out there. Recently, we've done a lot of work around Hadoop in terms of optimizing various Hadoop modules to run on Intel architecture processors, specifically the Xeon processor. And within that work, it's not just about the performance of the CPU, it's actually about security. We've been optimizing Hadoop to make it more secure, leveraging some of the features that we've built into the processors over the years. And we've also done some work with SSDs, solid-state storage devices, and networking. We had a distribution of Hadoop that we'd brought to market. We've recently made an investment in Cloudera, and are now working very, very closely with Cloudera to get them to integrate the updates we've made to Hadoop into their distribution, so they make them available to a broader community. At the same time, we feed these updates back into the normal open source community, such that they're available to all the other distributions out there.
Okay, thank you. The other interesting thing that came up was the virtualization of infrastructure. So currently it's down to the level of servers, as you said, but that will go down and trickle down even more. And I think that's also of interest for HPC, of course, because then you can quite easily combine and create your own quote-unquote HPC clusters. Can you comment?
Yeah, so the enterprise business has, for many years, has been a series of waves. They've gone through client-server, then server consolidation. We're into this virtualization phase at the moment where many people are taking one workload per server and virtualizing that down, so they run multiple workloads per server. And that's a precursor to private use of private cloud and hence public cloud, another topic that's been discussed here over the past couple of days. As part of that, so we've virtualized the server, so effectively we've got a software-defined server, if you like. You can distribute workload onto the server from the management console within the data center. We're now in the process of virtualizing is not quite the right word, but going through a software-defined mechanism for networking and storage. You hear people talk about SDN, software-defined networking, and software-defined storage. Today, many networks inside data centers are predefined. When you deploy the routers and the hubs, etc., that's it, you set your network fixed, which makes it very, very difficult to go and repurpose or restructure your network inside the data center. With SDN, we pull out the data plane and the control plane separately. So the control plane gets pulled away to another server, which then manages all the devices sat around the data center. So again, at the management console for the IT administrators, they can sit there and manage the network and redisposition the network, change the network settings very, very quickly. This actually enables them to have a more flexible data center and to handle new demands. So now we've got software-defined servers, if you like, we've got software-defined networking. We're going down the same challenge with storage, right? Storage used to be big monolithic blocks. We're now going to and again, you provision storage and that was it, it was fixed. We're now seeing an evolution in the storage environment, especially driven by the big data and the IoT type stuff where they've got huge amounts of new data coming in that they've got to be able to have a flexible storage environment. So we're going down also this software-defined storage. So that's the three key elements of the data center of being evolved so that they can be repurposed from the management console to the data center rather than having to go and physically touch them. The next layer beyond that is something we call software-defined infrastructure. So today, within the current environment, within the server, the standard building block you've got is a server. Right? It's a module, it's got processors, it's got I/O, and it's got memory. And you deploy that into your data center. And if you've deployed a lot of dual processor servers, and then you've got a workload that required some multi-processor servers, you're kind of stuck. You can't easily repurpose those servers to handle the more complex workload. What we're going towards is an approach where we separate out the server into compute, storage, and I/O as separate modules. And we interconnect those modules with a high-speed interconnect based upon silicon photonics. That then enables us to do software-defined infrastructure. So now we can actually reconfigure the physical infrastructure from the software layer. So now when we want to deploy a certain workload, we can actually determine what type of server infrastructure it requires from the management console, configure the data center to meet that need, and then deploy the workload into the data center. Now the application and the workload define the data center infrastructure, not the physical infrastructure itself. This becomes interesting when you look at analytics, right? We've spoken here about big data analytics. Big analytics infrastructure requires big high-performance computers with lots of memory. We're moving towards this in-memory technology, large amounts of memory required for that. You don't always want to run your analytics all the time. You may want to be able to repurpose, run them for a period of time. Then if you're not using it, so overnight when you're not running analytics, maybe that system's idle. With software-defined infrastructure, I can then reconfigure my data center and running a different workload on that infrastructure, utilizing all the servers but in a different configuration, or all the processors in a different configuration, and it gives me flexibility and efficiency. So that's how IT is going right today, and I think the HPC environment, you've got to pick up something similar.
Yeah, actually, I wanted just to come in on that because the 2 days before we have been talking about cloud and HPC and the usage of cloud for HPC. Now, taking what Alan has said on the more flexible infrastructure, right, which obviously is an enabler to cloud infrastructure in general. Let's look a little bit on how that is usable and useful for HPC as well, right? Because HPC, some people think of, okay, this is a very high-end focused effort of some institutions with very dedicated machines. Well, that's the case for some. But on the other hand, there's a large segment, which is actually a larger part of the market, let's call that mid-market HPC, which is looking for flexible solutions in terms of support of their high performance needs. And they can be on the floating point side, they can be more on the analytics side. Those things are merging and blurring anyway. So the usage of a more flexible infrastructure and then the usage on a different level for a cloud infrastructure is actually enabling high performance computing and high performance simulation and analytics for a larger user base, right, than you might think, right? One example, for instance, is in product design. Usually you have a development cycle of, you go on a CAD workstation, right, you design the product, and then, well, you need to evaluate it somehow. Many people are still using workstations for that evaluation and simulation part today, but if they are enabled by a more flexible infrastructure, by a cloud-like infrastructure where they can get access to higher performing systems very flexibly, to come to that point you made, then they will be able to develop their products faster and better than they are actually able today. So this is one other thing where the things are actually coming together between what we call big data analytics and high performance computing today. Right? And obviously we as Intel, we try to support that from several aspects, right? From the hardware aspect, right? We're bringing out the high performance server technology and products, right? But also from the software side, as Alan has pointed to, with our efforts in the open source space. Another interesting aspect is if you have those flexible infrastructure, you still have applications on top of that, right? Be them from the analytics side or from the high performance computing side. And as we see the hardware going more and more parallel with more cores, and within the cores more ability for data parallelism as well, and we are driving this very much to drive the performance up. The software needs to keep up with that, right? And what I mean is the application software, especially on the high performance computing side. So as an example, there's an initiative which we are driving from our side together with end users, which we call the Intel Parallel Computing Centers, where we actually work, in this case, with code owners who have so-called community code, which is being used by research, but also by industry in many fields, in bioscience, in mechanical engineering, in material science, right? To just give a few examples, to make those applications really capable of using the parallelism. That's why we call them parallelization labs, more or less, and take the performance which is offered by the hardware and the underlying system software up to the application level. So we think that's also important on top of the efforts we have both described on creating the infrastructure on the hardware and the software side. You also need to go up to the application level, specifically if you want to have high performance. And you get high performance through parallelism, and that's why we need to work with the software industry and also with the software community to achieve that.